Welcome, ladies and gentlemen, to Fluid Pressure Example 1, Part 2. Now, from Part 1, we were trying to find the function for g of y. So continuing, now we have the equation 10 minus y is equal to x plus 10. We need to get the x by itself because we're going to express x in terms of y. So we add negative 10 to both sides. The 10s on the right cancel, the 10s on the left cancel. And we now have that x is equal to negative y, or g of y, expressing x in terms of y, g of y is equal to negative y. So now we found the function expression for g of y. G of y is equal to negative y. We will now determine f of y. Well, x is equal to f of y, which now, rewriting the point slope formula so that we can have x expressed in terms of y, f of y using the point slope formula is now equal to y minus y1 divided by m plus x1. Our slope is equal to 15 minus 10 divided by 15 minus 10. We get 5 divided by 5. The slope is equal to 1. For our point x1, y1, x1, y1 will equal to 10, 10. So x1 will equal 10, y1 will equal 10. We will take this information and substitute it into the formula for f of y. So after substituting in our values, we have that f of y is equal to y minus 10 divided by 1 plus 10. Well, now that this is over 1, we simply have that f of y is equal to y minus 10 plus 10. Well, f of y is equal to y. So now we found g of y. G of y is equal to negative y. F of y is equal to y. So ladies and gentlemen, please remember we are working within the interval from where y goes from 10 to 15. And as you see from the diagram, the width will vary. So to find the width, we have to go f of y minus g of y. Well, in place of f of y, we substitute y minus. In place of g of y, we substitute negative y. W is equal to y plus y, which is equal to 2y. So now this is the expression for the width for the interval from where y goes from 10 to 15. Area of a typical strip that is microscopically thin is, according to this diagram, we now know that the width from where y goes from 10 to 15 is given to us as 2 times y sub I, and the microscopically thin height is delta y. So height times the length gives us area. So delta A sub I is equal to 2 times y sub I times delta y. From our diagram, we see that over both parts of the dam, a typical strip has a depth of 15 minus y. So from y equals 10 to 15, the typical strip within that interval has a depth of 15 minus y. Now we have the following. Area times depth is equal to cubic feet. One more time. Area times depth is equal to cubic feet. Remember that the density of water is 62.4 pounds per cubic feet. So, our incremental force on the vertical wall of the dam from y equals 10 to y equals 15 is delta F is equal to 62.4 pounds per cubic feet times 2y times delta y times 15 minus y, and that's in cubic feet. So delta F is equal to 124.8 times y times 15 minus y times delta y. As we let the partitions approach zero, the total force on the vertical wall of the dam is given to us and now becomes an integral. F is equal to 1,248 times the integral from 0 to 10 of 15 minus y times dy plus 124.8 times the integral from 10 to 15 of y times 15 minus y dy. F is equal to 1,248, please forgive me. Again, F is equal to 1,248 after taking the integral times 15y minus 1/2 y squared, and the interval of integration is from 0 to 10, plus 124.8 times the integral. As we go from 10 to 15, I distribute it through by the y, so we now have 15y minus y squared dy. So F is equal to 1,248 times 15 times 10 minus 1/2 times 10 squared plus 124.8 times 15 over 2 after taking the integral times y squared minus 1/3 y cubed. The interval of integration is from 10 to 15. F is equal to 1,248 times 150 minus 50 plus 124.8 times 15 over 2 times 15 squared minus 1/3 times 15 squared minus, in parentheses, we have 15 over 2 times 10 squared minus 1/3 times 10 cubed. After doing further simplification, we now have that F is equal to 124,800 plus 124.8 times 145.83. Finally, the total force on that wall is equal to 142,999.584 pounds. Ladies and gentlemen, this concludes this video instruction on fluid pressure. Please let me know if this video was clear, easy to follow and understand. This is another example of the type of customized video that you will find on your private site that goes along with your personal one-on-one tutoring. So I develop customized videos for the problems that you're working on, so that after our one-on-one consultation in our tutoring session, you can go to your site and go through the customized videos that I have produced for you. So again, my name is Mr. Davis. I am the Math Healer. Thank you for joining me. Have a very good day, and come visit me at mathhealer.com. Have a very good day.